Hello everyone, in this video I'll discuss integration by parts. So this method allows us to integrate integrals of different forms if you have product of algebraic function and exponential function, or if you have product of an algebraic function and a trigonometric function, or algebraic function and logarithmic function. So it can be any log, natural log, or the common log, or any other log. And similarly, we can also do the integral of inverse trigonometric functions using this method, or the product of two algebraic functions. So these are the basic forms that we can solve using this method. So what exactly is integration by parts rule? So it comes from the product rule of derivatives. So recall that the product rule of derivatives says, so if your function y is a product of two functions u and v, where u and v are functions of x, so then if you take the derivative on both sides, so we know that derivative of u times v is equal to, so you use the product rule, u times dv over dx plus v times du over dx. And if you want, you can multiply throughout by our differential of x, and we are left with this differential form. Differential of u times v is equal to u dv plus v du. And now if we integrate this equation on both sides, so we get uv is equal to integral of u dv plus integral of v du. And in the end, just a bit of rearrangement, we get integral of u dv is equal to u times v minus integral of v du. So this is our rule for integration by parts. It looks weird to start with, like you have integral on this side and then you're writing that as two other terms in which one of the term is integral. But this formula is used to replace the integral on the left by another, hopefully a simpler one, simpler integral on the right. So integral of u dv is equal to uv minus integral of v du. So whenever we have a problem, the first step is to choose u and dv. And how do we choose u and dv? So we choose u as something that gets simpler on differentiation. So we choose u as that factor which becomes simpler, or which is reduced upon doing the differentiation, and we choose dv, the rest of the other factor, which we can integrate easily. So it's very important that you choose your u and dv carefully. So let's take a look at this example 1. So here we have integral of x cosine x dx. So we know that the derivative of x is just 1. So it means it reduces, like the degree becomes less and less when we do the differentiation. So we're going to choose x as u and cosine x dx as dv. So choose u as x and dv as cos x dx. And now we have to plug in the values in this formula. So the right hand side of the formula says you need a product of u and v. So it means we need to evaluate v, and also we need to evaluate du, so that we can put the values in our formula. So in order to find du, we're gonna just take the derivative of x. Differential of x would be 1 dx. So differential of u will be equals to differential of x. Similarly, in order to find v, we take the integral on both sides, and integral of cosine x is equal to sine x, and we don't put a plus c here because we're gonna do that in the end of our example, so there is no need to put a plus c here. And our integration by parts formula is, so integral of u dv is equal to uv minus integral of v du. So if we just notice it, so it's like multiplication of u and v. So diagonal multiplication, right? So multiplication of u and v, and then integral of v du. So we go diagonally, and the horizontal row we do the multiplication, and we get our integral on the right hand side. Thus using the formula here, so plugging in the values, so u is x, u times v minus integral of v times du, which is just dx. Thus in the next step we get x sine x minus integral of sine is negative cosine, and negative and negative becomes positive, so we get positive cosine x, and since this is an indefinite integral, we're going to add a constant of integration. So this is our required integral. So just a recap, for integration by parts, we use this formula, and it is equal to uv minus integral of v du. And the most important step is to choose your u and dv. So u, we choose the factor which becomes simpler on taking the derivative. So quantity u is normally chosen such that the derivative is of simpler form than u, and other one would be your dv. Let's take a look at the next example. Sometimes you have to do integration by parts more than once. So let's see what happens in this example. So here we have integral of x square sine x, and we notice that, so for x square, since this is a polynomial function, when we're going to take the derivative, it's gonna reduce to a simpler degree, right? So it's gonna be simpler, so this will be our u, and the other one will be our dv. So we're going to take the differential of u on this side, so du would be 2x dx, and taking the integral of dv, we get v is equal to, so integral of sine is negative cosine x. So putting in the values of our integration by parts formula, we get, so u times v, so we're gonna do u times v, and minus integral of v du. U times v means x squared times negative cosine x, minus integral of v, which is negative cosine x, 2x dx. So in the next step we get negative x squared cosine x, and we get plus integral of, so 2 I can take out, so integral of x cosine x dx. And now we notice that we again get an integral which we can only solve using integration by parts. So we have to do integration by parts again. So we get negative x squared cosine x. And for this one, again, we need to choose our u and v. So u should be the factor that differentiates to a simpler form. So x would be our u, and cosine x dx would be our dv. So u equal to x implies du equal to dx. Similarly, dv equal to cosine x implies integrating, we get v is equal to sine x. And now we're going to use our formula, integral for integration by parts formula. So it would be uv minus integral v du. So plugging in the values here, we get, so u is x, v is sine x, and then we're gonna multiply v du, and we're gonna take the integral of this row, minus integral of sine x dx. So we got negative x squared cosine x plus 2x sine x, and integral of sine is negative cosine, so we get positive cosine x. And of course, in the end, we're gonna add a constant of integration. So this is our required solution. So sometimes we need to do integration by parts more than once in order to solve a problem. So I know that I have told you that you need to choose the term as u, which becomes simpler upon differentiation. But there is a rule of thumb that you can use to choose between u and dv. So one method that is prevalent is called isolate. So you go by this mnemonic isolate, or sometimes people even use lighty. So whatever works for you. So you can use any of them. So isolate, for the I stands for inverse trigonometric functions, inverse trig functions. L stands for logarithmic functions. It can be natural log or it can be common log. A stands for algebraic functions like your polynomials, etc. T stands for trig functions, and E stands for exponential functions, exponents. So whatever comes first in this, so choose that as your u. So whichever comes first, so choose that as u. So that would be your u. And of course, the other one as gv. And it works in most of the cases. So that's our general rule of thumb for choosing u and dv. Isolate. I late. We can apply this in the next example that we're going to do now. So in this example, we have integral of e raised to power x sine x dx. So using our rule of thumb, so we should choose, so trigonometric functions comes before the exponential. We will choose this as our u and ex dx as our dv. So u is sine x and dv would be ex dx. In reality, it doesn't matter which one you choose as u and which one you choose as v here, because we know that trigonometric functions, so if you differentiate, you're going to get cosine and then again sine. So it's like cyclical, and here you're going to get ex, e raised to power x, no matter what. So you can choose either of them as u and dv. In this case, it wouldn't matter. But let's just use our rule of thumb. So differentiating, we got, so du is equal to cosine x dx, and integrating on the other side, we got v is equal to e raised to power x. Then we plug in the value in our rule. So integral of u dv is equal to u times v minus integral of v du. So this becomes, so diagonally we multiply u times v and then minus, we go horizontally and we took integral of this product. So e raised to power x sine x minus v, which is e raised to power x, and du, which is cosine x dx. And we notice that here again we have an integral in which we have exponential and trigonometric functions. We need to use integration by parts again. So in this case, we choose u as cosine x and dv as e raised to power x dx. Thus, the differential of this would be negative sine x dx, and the integral of dv would be e raised to power x. So again, we're gonna do u times v diagonally, and then v times du, and we're gonna subtract this integral. So that gives us integral of e raised to power x dx. So we're going to use our formula u times v minus integral v du. Plugging in the values, we get, so u times v means e raised to power x cosine x minus integral of e raised to power x and negative sine x dx. So this will become positive sine x dx. And now we notice that we get e raised to power x sine x dx is equal to e raised to power x sine x minus e raised to power x cosine x minus integral of e raised to power x sine x dx. So now you will think, oh, we again got something that we need to do integration by parts. But the catch here is, if you notice, this integral is same as our original integral. So it means here we have one copy and here we have one copy. And if I add this integral on both sides, so I will get twice of this integral equals to these two terms. So now we can combine these integrals together. So we don't need to do integration by parts again. Otherwise, it will be never ending process. Thus, adding this integral on both sides, we get twice of the integral ex sine x dx is equal to e raised to power x sine x minus e raised to power x cosine x. And in the next step, you will get integral of e raised to power x sine x dx is equal to, so we're going to divide both sides by 2. So we get half e raised to power x sine x minus half e raised to power x cosine x. So I'm just going to take half common. And in the end, since this is an indefinite integral, so we're going to add plus c. So this is your required solution. So sometimes when we do integration by parts repeatedly, we end up having the original integral, and in that case, we just bring those original integrals together and do some algebraic simplification in order to find the value of required integral. So this is how we use integration by parts, and the trick is you're going to choose a u and tv, and for that you can use this isolate mnemonic. So whatever comes first in isolate would be your u and the other one would be your tv. And once you're done with the right choice, you can use this formula to evaluate your integral. So I hope you enjoyed this video. In the next video, I will show you a shortcut method for the integration by parts. That shortcut method is very helpful even in doing the repeated integration by parts. So please do watch the next video as well. So thanks for watching.